we like to do is we like to look at a couple of questions. First, we like to find the determinant of this 5 by 5 matrix. It's gonna be somewhat, tough it seems, but we'll see what we can do. So I could have gone through any way that I want to, but maybe I'll try to find the determinant of this one by going through the first column. Or actually, yeah, first column. If I go through the first column, so second, third, fourth, second, third, fourth, fifth, all of them are equal to 0. So I know that this one will be equal to, and then this is first row, first column value, so 1 plus 1, which is 2. Hence, when the sum of the row and then column becomes even number, it becomes positive. So I'm going to have a positive 1, because this is 1, times the determinant of the minor becomes everything within them. So we have 2, 4, 6, 8, 0, 3, 6, 9, 0, 0, 4, 8, and then 0, 0, 0, 5. Now, but since this is 1, it doesn't really matter what it is. Now I'm going to take the determinant of this 4 by 4 matrix. Once again, on the first row and first column, I have 0, 0, 0, I have 2. So I'm going to expand my determinant about this 2. So that means my next value, this is the same thing as 2 times. My minor now becomes these 3 by 3 inside over here, 3, 6, 9, 0, 4, 8, and 0, 0, 5. Now 2 was already there. Now what I'm going to do is I'm going to expand this one by the first column once again, which is simply 3 alone, because the other 2 are equal to 0, so I have times by 3, and the minor becomes 4, 8, 0, 5. So then I know that 2 times 3 becomes 6, and the determinant of this 2 by 2 is rather simple, so these 2 multiplied by together, so we get 20 minus 0, so times 20. And our final answer becomes 120. Interestingly, when my lower triangle is equal to 0, my determinant ends up being the product of all these values on the diagonal. Now, let's look at the next question. Number 27. Evaluate determinant of B by expanding by the second row. So they want you to first expand it by this row. Then if I were to do that, what do I get? First, I have -2, but what's the sign in front of -2? Since this is second row, first column, so 2 and then 1 add up to be 3. Since this odd number, I have to multiply this one by 2. Multiply by negative sign. And then, what remains? Boom, boom. So I have 1, 0, 0, 3. Since the first one was negative, second one must be positive. That means positive, -1, which is same thing here. And then 4, 0, 4, 3. Lastly, we have another, now -1, not plus, because it has to alternate. -1, 4, 1, 4, 0. So what is that equal to? First one is 2 times 3. Second one is -1 times 12. Third one is -1 times -4. So then what we end up getting is this one is equal to 6 minus 12 plus 4 is equal to -2. So -2 is the determinant of this matrix when I expand it through the second row. What if I try to do the same thing, but expanding it through the third column, which means this one? First one is equal to 0, so I don't have to worry about that. The second one is 1. But this is a second column, a second row, third column. So sum is odd number, so we have -1. And then we have 4, 1, 4, 0. Same way as before that we have done. And lastly, it's 3. So it's going to be third row, third column. It's going to be positive 3, and then here 4, 1, negative 2, negative 1. So for the first one, it becomes positive 4. Second one is plus 3 times negative 4 minus negative 2. So this is plus 2, so we get negative 2 here. So 4 minus 6 becomes negative 2. So as you can see, in either way, we're going to get the same answer. So our answer is what? Agree. All right, with that one, I'm going to close up, and I'll see you later.